Hello everyone, I'm part of the Tracy I Makerspace team, and today I'll be showing you our Arduino powered vehicle. So to start off, we have a little swivel in the front to help with the steering. You have the breadboard to help with the wiring through the Arduino, which powers it. So to start off, I'll show you how to flip the switch. Show you how to flip a switch.
I'll flip the switch and show you how it works.
When you flip the switch, it allows the wheels to move.
So right here we have the circuitry, which it looks like a mess because it is. So what you have first is the pin 13, which goes to number 8, which goes to the base from the transistor. The way the transistor works is it'll receive an input, and that input will switch where the ground goes, and it needs this resistor to resist some power, or else it'll receive too much electricity, and you don't want to do that because then you can destroy the transistor. And once this goes in, it'll get the circuit it'll move the ground to the ground of the car, which is this right here, this wire, if you can see this one, this one, and this blue cable goes from the negative. This is where the ground switches to, actually, is it goes from the ground from the Arduino to the ground of the battery pack, which is how it receives more power. And yeah, that's pretty much how this works. We have a switch hooked up to it, and the switch will allow it to turn on and off, as you can see. I don't want to put it on the ground because it'll fly, unless you want to see that. I do that. Yeah, not good. As I said, the circuitry's a mess. We weren't really able to deal with it because we needed the alligator clips to make sure everything was able to touch each other. Alright, these yellow motors are 5-volt motors, and the Arduino does have a 5-volt pin right here, but it is not able to distribute the power equally to both motors, so one motor will have more power than the other. That's the point of the battery pack on the bottom, which Kyle showed earlier. And the battery pack provides external power because of the Arduino's insufficient power outage. So the circuitry doesn't look good, and that's because the pins on as you can see on the motor, we have to tape it because this motor is broken. There's no little pinholes for it as there are in this one. Oh, I forgot to mention, there's a diode here, and this diode makes sure it only can flow one way, as you can see right there. Yeah. The diode makes sure that the flow only goes one way and cannot be received another way, which can mess up the circuitry, and it can make the tire actually spin the opposite way. Because these motors are actually reversible, the way you put the positive and negative will depend on the way the motor spins forward or backwards. And yeah.
This image displays the circuit we use in our design. The black and white item on the end of the motor is called a diode, and it makes sure the circuit only flows in a specific direction. The pin that the transistor is connected to is different on our design, as it is connected to pin 13 instead, but it does not make that big of an impact as you can use any pin. The restrictor is connected to pin 13 to make sure not a lot of voltage is emitted from the Arduino to potentially fry the transistor, which would ruin the circuit and device in total. The transistor is also connected to the negative of the motor because the way a transistor works is it switches the ground of the circuit, which will change the flow of the circuit since it will complete one circuit while disconnecting the other. This is shown when the pin, in our case pin 13, emits a pulse from the Arduino every second it is changing the flow of the circuit, from an empty or dead circuit to the circuit using the external battery pack we have connected. This allows for a higher voltage to be used and also allows us to control the car with the Arduino via the transmitter and pins.
Before the step of the code, we define exactly what pin 13 will be called, which is motor pin. Right there. This is mainly so we don't need to hard code pin 13 every time we desire to use it in the code later on. So in the setup of the code, which begins right here, we tell the Arduino to output from the motor pin, which is right there, which we define as 13 because that's the pin we use for the breadboard in the circuit. Telling it to have output means that it'll be outputting electricity instead of receiving. In the loop, we tell the Arduino what to do, repeating until we specify it when to stop. The Arduino will digital write, which specifies whether it will be high or low on the pin. High meaning it sends power, low meaning it is sending none. We start the loop by sending power to the transistor, which will switch the circuits to flow from the empty circuit to that of the external battery. Then wait 1000 milliseconds or 1 second. That is what the delay of 1000 means.
After the 1 second is finished, it stops the voltage from the Arduino, which would break the circuit from that of the battery, switching it back to the empty circuit, waits 1 more second, and then starts the loop over again, which would then send the circuit power, switching the flow, and repeating endlessly unless coded otherwise.